So now we'll have a look at groundwater quantity, and the concern here is reduced pressures or access, and what the information that we've got around quantity is the systems and their rights, and then the levels and behaviour. So I'll go through those one at a time. This map shows the 4 main groundwater source types that are within and overlie the Gunnedah Basin. These units are based on the underlying geology and hydrogeology and are used by the New South Wales Office of Water in their management of groundwater extraction and sharing in this area. The green represents the porous rocks of the Gunnedah Basin, which we will refer to as the Gunnedah Basin for the remainder of this presentation. Porous rocks are sedimentary rocks such as sandstones, shales, siltstones and claystones, and coal. These porous rocks form deep regional groundwater systems and are where the coal seams are located. The hatched area that overlies much of the Gunnedah Basin is the southern and eastern portions of the Great Artesian Basin, commonly known as the GAB. The GAB is also a sedimentary basin made up of porous rocks. The purple areas represent the shallow basalt caps and flows that overlie the porous rocks in the southern areas on this map. The yellow represents the shallow but extensive alluvial deposits in the area. The main deposits are the upper and lower Namoy and the Gunnedah, with some smaller areas of alluvium along the Macquarie and Castlereagh rivers. Alluvial systems are made up of sands, gravels and clay lenses and often contain high quality water with very high yields and are targeted for water supplies. The groundwater volumes discussed on the map are in a unit called gigalitres. A gigalitre is equal to 1 billion litres or 1,000 megalitres. Across all of the groundwater sources within and overlying the Gunnedah Basin, there are approximately 340 gigalitres of groundwater rights. The pie chart here represents the groundwater rights in the upper and lower Namoy and shows that there are approximately 215 gigalitres in these alluvial sources alone. Irrigation is the dominant purpose, with over 80% of the water used for irrigation. The colour scheme in the pie charts represents the purpose for which rights are used. Navy blue represents irrigation, green is stock and domestic, orange is town water supply, and brown represents industrial and mining uses. This next chart is the Lower Gunnedah alluvial groundwater source, which has a smaller volume of approximately 28 gigalitres, but similar irrigation dominance to the Namoy. Here we have the Macquarie Bogan alluvial groundwater sources, which total 22 gigalitres and again are mainly for irrigation. The remainder of the alluvium overlying the Gunnedah Basin is shown here at about 4 gigalitres. In total, alluvial rights overlying the Gunnedah Basin are 270 gigalitres. No further rights are being granted in alluvial systems, and these rights represent the sustainable extraction limits for each water source. The Great Artesian Basin is represented here, and you can see the volume of actual groundwater rights is less than 10% of the total alluvial groundwater systems. There is also a significant proportion of free-flowing water from uncapped bores in the Great Artesian Basin, about 10 gigalitres. This is shown in the light blue. This is essentially water that is flowing to waste or evaporating. Interestingly, there is a much smaller proportion of use of Great Artesian Basin water for irrigation due to the type of salts and their limited suitability for irrigation. We can see it does provide a significant source of water for stock and domestic supplies, particularly further west. The next chart shows the groundwater rights in the New South Wales Murray-Darling Basin porous rock source, or the Gunnedah Basin, which has 22 gigalitres per year in total. This is less than 10% of the alluvial rights. While irrigation use dominates in the east, there is stock and domestic use as well as mining and industry within the Gunnedah Basin. The final chart shows the groundwater rights in the basalts are small, about 3 gigalitres, and mainly used for stock and domestic purposes. We've then got the same information, but we've got it prepared as a cross-section. Now this cross-section goes right through the middle of that basin, and we've just presented that so you can have a look at the relative depths and where these bores are. So that we can see the layers, the cross-section is vertically exaggerated. So it's 1 kilometre of depth and over 100 kilometres wide. The systems are shown using similar colours to the previous map, with alluvium in yellow, Gunnedah Basin in green and blue, and the Great Artesian Basin in orange. There are also 2 pie charts representing the use, with the top pie chart colours relative to purpose and the bottom one relating to the volume distribution across the different water sources. We can see in the bottom pie chart that about 80% of the total 340 gigalitres of rights overlying the basin are in the yellow alluvial systems. These rights are taken from over 1,500 high-yield bores and about 4,500 stock and domestic bores. It is worth noting that these alluvial systems are small in size compared to the other systems, with a thickness of up to 150 metres, but mostly less than 100 metres. They are made up of sands and gravels, have high volumes and good quality water. Alluvial systems are intensively managed under water sharing plans. The Great Artesian Basin is represented by the orange colours, and note the large reliance on Great Artesian waters for stock and domestic purposes in the more arid zones, with over 3,500 bores. There are only a few higher yielding bores, mainly in the eastern margins where the water is fresher. The porous rocks of the Gunnedah Basin are illustrated in the green and blue. Again, there are large numbers of stock and domestic users in the shallower parts of this system. Note that the blue Permian rocks and associated coal seams actually outcrop at the surface and are in direct contact with the alluvium in some areas on the east. This is where open-cut coal mining commonly occurs. The coal seam gas operations are proposed in these deeper seams, and you can see the difference in the depth of the targeted coal seams for gas companies compared to the depth of the typical water supply bores. At this stage, according to the March 2014 preliminary environmental assessment commissioned by Santos, a maximum of 850 individual gas production wells are proposed in the porous rocks of the Gunnedah Basin associated with the Narrabri gas project. Just going back to the map here, you can see the areas where the Permian rocks outcrop in blue. These are the areas where coal seams potentially outcrop or directly underlie alluvial deposits. So now if we look at the volumetric risk. So these are the same systems again, just with the bar chart this time, so it's the same information on these charts. What we've got here is the alluvial systems, and you can see that that's blue right to the top. These systems are at their sustainable limit, so they've been fully allocated. They are operating to what, there's no spare water in these systems, they've hit their sustainable yield. Same with the Great Artesian Basin, but you can see here in the Gunnedah Basin you've actually got unassigned water. So this is the sustainable yield or the long-term limit sitting up here, but these are where the rights are. So there's room to grow in that system, and the fractured basalts are at their sustainable limit as well. Santos estimates that over the life of the Narrabri project, the average volume extracted annually will be 2 gigalitres. This water will be taken from the porous rock sediments of the Gunnedah Basin. As we can see, there is unassigned water in this groundwater source. The 2 gigalitres represents a small proportion, approximately 1.8%, of the sustainable extraction limit as defined in the Murray-Darling Basin Plan. It represents approximately 10% of the current rights in the Gunnedah Basin. Some have expressed concern that extracting from porous rocks will impact on the overlying systems. The main concern is about the impacts on the highly used alluvial systems. Let's put aside the issue of impact and instead consider this issue in simple volumetric terms. The 2 gigalitres represents less than 0.75% of all the rights to alluvial groundwater overlying the Gunnedah Basin. It represents approximately 1% of the rights in the upper and lower Namoi alluvial groundwater sources. And it represents less than 4% of the rights in the upper Namoi alluvial groundwater sources that are closest to the Narrabri project, that is zones 2, 4, 5 and 11. Just one more important point should be made here. Coal seam gas companies will need licences to take water under New South Wales water legislation and the aquifer interference policy.